Alright, let's see. Looks like maybe I won't reach double digits in my streak. Unless I conquer this hard. Maximize the distance between points on a square. Give an integer side representing the edge length of a square with corners at 0, 0, 0, side, side 0, and side, side on Cartesian plane. We're also given positive integer k and 2D integer points where points at I, x, comma, y represents the coordinates of a point lying on the boundary of the square. Okay, sure. You're given you select k elements among points such that the minimum Manhattan distance between any two points is maximized. Select k elements among points such that the minimum is maximized. Okay, so they're kind of like as spread apart as possible. Return the maximum possible minimum Manhattan distance between the selected k points. I have a suspicion that I might be able to solve this. So you need to pick 2 points. So you pick these two or these two. Manhattan distance is just the sum of the x and y deltas. Sum of the delta x and delta y. Okay, so 2 plus 2 is 4. Oh, you select k elements. Is k not given? K is 4 here. Yeah, select all 4 points. Okay, yeah. Here you select 4 points. So to keep it as far apart as possible, I'd select maybe this one, this one, this one, and this one. So minimum is just 1. Yeah, you just can't do better than that. Yeah. If this was maybe over here, no, even that wouldn't work. Are these all integers? Yeah, these are all integers, so at least it's not something with square roots. Here you need to select 5. Again, it's just 1. These examples are horrible. Okay, so I think what I can do is probably do binary search for the distance and see if I can't come up with a better distance each time. So for binary search, I just need to have it's like I guess, I'm gonna guess the minimum separating distance for the k points. There is the slight difficulty of which point I start off on, but it just needs to otherwise be, I need to have a single pass function, or a function that does a single pass over the points array that determines if a given distance is feasible or infeasible to be the minimum distance. So if like the minimum distance is guessed to be 3, then I somehow do a pass over all the points and verify that 3 is a valid separating value for every point, or for k points in the array. What I think I want to do is actually can I just rearrange the points array so they're all on a number line? like, could I imagine a number line that just goes counterclockwise from the origin to this point, this point, this point, and put the points on them and say that the distance between these points on that number line is equivalent to the distance that it would be on the square? I don't think so, huh? Because this thing over here, if I were to lay this out, this point would be over here, but it would be much closer than that. It's close. If the two sides are adjacent, then I could put this on the number line, and the distance that those points are on the number line would be the distance that they would be their Manhattan distance. But this thing backtracks. Backtracking is making it really hard. How would I map this to something that is easily comparable for distance? This is 2 away, 3 away from the origin, 4 away, and this is back to 3 away. One, two, three, 4. So the maximum distance would be here. Maximum distance if the points were at the opposite diagonals. 2, 3, 4. I mean, could I do something where something where I make this thing go this way and this thing go this way, kind of like splitting up into, like, this is positive on the number line extension, and these two sides convert to a negative on the number line extension. Then I still need to compare, like, points here to points here. How many points am I dealing with here? 10 to the 5th, probably. 15 times 10 to the 3rd. 4 times side. What the fuck is this? Points is, the length of points is minimum of 4 times side. Okay, so it's like 4 times 10 to the 9th. Or 15 times 10 to the 3rd. So it is at most 15 times 10 to the 3rd. Is that right? The minimum between those two values. Yeah. At most 15 times 10 to the 3rd. So I would need to select k values where k is at least 25. that could be all the points. All the points would be easy in some ways. All the points. I don't think anything here is easy. If I did use all the points, how would I find the minimum? Two, one, 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 one. You'd have to do a graph. We have to do a graph. Two. So, in theory, if say this is actually like 5 length here, or let's say side length here is 10. The closest this thing could be could it be, yeah, so if there's a point here and a point across from it, then this distance would be 10. But then let's say that there was like another point here. The distance, this point would be farther away than to this point than it would be to this point, which is a little problematic just to keep things ordered. So how would I determine that distance? Because it's not in any order. It's almost like random. I could do a graph. No, that's stupid. So point has neighbors to its left and right on the boundary, but the distance to its nearest, I guess if it's on the same side, the point would have to be closer to that than something on the opposite side, for sure. But the point could still be closer towards another point on a different side than it is to the remaining point. So like if this was over here, this point here would be closer to this point than this point. So it's 15 times 10 to the third. If I did every point versus every other point, that'd be 225 times 10 to the 6 divided by 2 or so. So roughly 10 to the 8th. 10 to the 8th. To find the distance between every point, every pair of points. I mean, seems a little inefficient, to be honest. maximize the distance between points on a square. Maximize the distance between points on a square. If I compare every point to every point, find the distance. Even if I knew the distance between the point and its neighbors on the side, neighbors on its boundary, and maybe even the distance between that point and its nearest neighbor, farthest neighbor. I guess it would be the nearest neighbor elsewhere or in totality. I think. Could I? Is it possible for me to go around the square finding points in that fashion? Pretend the points are on a number line. Jump to the next number on the number line. I wouldn't know which point to start with, because that probably matters. If I start at the wrong point to pick for the K. Let's pick K values. K being something between 1 and points.length, the minimum between 25 and points.length. Okay, so K is at most 25, I guess. Right, because 25 is smaller, or points.length is smaller, so it's K is at most 25. So at most 25 points I pick. It's dynamic programming. 25 is pretty big for the length of the dimension. I have to pick through case 25 at most. Points.length equals min 4 times the number of sides. So this could be a huge number, or it could be 13 times 10 to the third. 15 times 10 to the third is 15,000. So 15,000 points. all line the boundary of a square. Select A elements among the points such that the minimum Manhattan distance is maximized. Was it for the fact that this was a square, this would be pretty easy, to be honest. If this was just points on the number line. If this was just points on a number line, I'd probably use dynamic programming or binary search. Is there some way of modifying either? So let's say for the brackets, the bars are where the corners are. If I convert the points to something that is on a number line, unroll the perimeter points to be points on a number line, then these two are correct relatively to each other. Then this stuff should almost go closer towards this side. Or I guess maybe, yeah, closer to that side. Yeah, so let's say a point that's in the middle is 1, 2, 3, and 3 away from each of these. Then point here is just 2 away. So what does that mean? For a given point, there is a maximum distance that other points could be away from it, kind of. So if there was a point here, so from this point to this point is the maximum, and then here it would go backwards. There's just no consistency there. And there's no way for me to make an easy drawing here. There's a point here. So 1, 2, 3. And it's like 2.9, 2.5, 2. If this point was over here. Or I guess this point here to this point here is 4 is the maximum, and then it goes backwards from there. But if it was something like if the point started here, then the maximum would be 1.75, 0.25, 2.25, 2. What am I thinking here? From here, 1, 2, 3. From here to here would be 3.5. From here to here would be 2.5. 0.5, 2.5, back to 2, 2.5 to 3. Is that right? Here's here, 0.5, 2.5, 2, 2.5, 3.5. Yeah. Yeah, this is 4, this is 3.5. If it was like right here. What is the pattern? What is the pattern? So from here to here, from one side to the opposite side, it's going to be, the point is going to be the side length distance. So here to here is 2. And then from there, it's going to be at most the same distance from the corners as the side it's on. This is 0.5, then this is going to be 2.5. This is 1.5, then it's going to be 2 plus 1.5, so 3.5. So there's 4 sides. For each of those sides, you have to determine the kind of numbering, the mapping of the points on that side to the distance. That doesn't seem very easy. Or doesn't seem very fast to do. What is going on? Selecting K points. Return the maximum possible minimum distance. Maximum possible minimum distance. I mean, could I just form a graph? Could I form a graph? Where every point connects to every other point. Does it make sense to do that? Oof. Would it be I mean, I guess the three relevant points for an E. Maybe I only need to store like the left. What the for each point I store what the two closest points to it. Would that be enough? The three closest points to it. And then try to find it that way. Is it possible to make this a graph? Every point says 15, so in the worst case it'd be n squared. So it'd be 15 times 10 to the third, so 15,000 times 15,000. It's n squared or n squared divided by 2, one of the two. Which I said was roughly a million, right? 15,000 times 15,000 divided by 2, 1.1 million. So for each would that work? If I were fed a graph and if I were fed the graph and a distance, a minimum guess distance between points that can be maintained, I wouldn't know which point to start with. And how would I traverse the graph? So if I go from one node to what? One node to all the nodes that have a distance greater than one node to the next closest node that has a distance greater than or equal to the guess. Would that always work? To be greedy. Definitely don't want to do from one node to its farthest node, or to a node whose distance is shorter than the guess distance. So node to its closest neighbor. So I would need to have all the neighbors. That doesn't make sense either. One node to all its neighbors. Too much calculation or too much storage, I think. Too much storage. C'est la vie. save. Alright, time for bed. Maybe I'll come up with something in my sleep. Oh, yeah, coding on fire. I feel you, buddy. Hope you